It started with a tremor, not a quake, not a crash, just a pulse. A silent whisper from the moon's core, too subtle for human ears, but not for NASA's machines. And that whisper, picked up by an aging sensor, buried in old Apollo mission data and amplified by modern artificial intelligence, has triggered a storm of questions across the scientific world. One of the loudest voices to rise from that storm? Professor Brian Cox. And what he's saying now isn't just startling, it's a warning. A quiet, profound call to look deeper into the moon and ourselves. For generations, we thought the moon was dead, cold, still, a cosmic relic hanging in the sky, its story long told and its fires long extinguished. But what if we were wrong? What if the moon, our constant glowing companion, has been hiding something all along? The first clue came decades ago, when Apollo astronauts planted seismometers on the lunar surface. To everyone's surprise, the moon rang, like a bell, a strange hollow reverberation that hinted at internal movement. But it was faint, intermittent, and with 1970s technology, hard to interpret. So we filed it away, assuming it meant little. We were wrong. Now AI is reading those dusty recordings with new eyes that never sleep, that never forget. And it found something no one expected. A single pulse, a distinct seismic signal from deep within the moon. Not a surface tremor, not a meteor strike, but something else, something older, deeper, and more mysterious. When Brian Cox saw the data, he didn't react with excitement. He paused. And then he warned. Because this pulse might be more than just geological noise. It might be a sign, a final murmur from a dying core, or worse, a shift. You see, inside the moon, something is still moving. The moon, it turns out, isn't completely frozen. It has an iron core, just like Earth, though smaller, weaker, quieter. But it's not silent. And the data, now refined by advanced algorithms, suggests that core is changing. Not erupting or collapsing, but shifting, ever so slightly, reshaping the moon's mass, its gravity, and potentially its orbit. Why does that matter? Because the moon isn't just a passive light in the night sky. It's the reason Earth is stable. Its gravity locks our planet's tilt in place. That 23.5-degree angle gives us our seasons, our weather, our rhythm. Without the moon, Earth's axis would wobble chaotically, like a spinning top, making climate swings more extreme and less predictable. The moon holds our world steady. But if its mass changes, just slightly, over thousands of years, the effect on Earth could be real. Subtle, slow, but real. This isn't about next year or the next generation. It's about the deep time of planets, the quiet, glacial forces that shape worlds over millennia. And right now, we are being offered a glimpse into that invisible clockwork. When Brian Cox says we're overlooking something important, he isn't pointing to doom. He's asking us to listen. Because what NASA has discovered with the help of AI is this. There are patterns, tiny patterns, in the moon's seismic behavior that we dismissed decades ago. Signals that didn't fit our expectations. So we labeled them noise, errors, anomalies. But now we know they weren't mistakes. They were messages. The moon is active, just enough to be fascinating, just enough to be unpredictable. It might be leaking, slowly, a whisper of gas, helium, argon, escaping from pockets buried in the mantle, trapped there since before life began on Earth. These aren't little puffs. These are vast, ancient vaults of volatile matter. And if they're being disturbed, if those gases are shifting the moon's balance, it could explain something else scientists have quietly puzzled over for years. Gravitational anomalies, moments during past lunar missions when spacecraft briefly drifted off their expected paths. Minuscule deviations, barely noticeable, but real, like the moon tugged just a bit harder, or not quite enough. We thought it was instrument error, but maybe it wasn't. Maybe the moon was shifting, just a hair, in response to something happening deep inside. If that's true, then we have to reconsider everything we thought we knew about the moon. Because now, scientists believe that deep within its interior, pressure is building. Not explosive pressure like a volcano, but structural, geological tension, like a sphere slowly, quietly changing shape under its own fading heat. The moon is shrinking, wrinkling, still contracting as it cools. And that creates stress. And where there is stress, there is risk. Brian Cox's concern isn't about catastrophic collapse, it's about complexity. He's not sounding an alarm for the public. He's whispering to the scientific world, pay attention, because we might be witnessing the final breaths of a living world, a planetary body in its twilight, still shifting, still whispering, before it goes silent forever. And that moment, that final breath, is something we can study. If we listen, if we act, we have the tools, we have the data, and now we have a reason to care. Because if the moon really is still trembling, even slightly, that means something extraordinary. It's not too late. Not too late to learn. Not too late to prepare. Not too late to understand that the moon isn't just a rock. It's a living history book. A relic from the dawn of the solar system that still has one final chapter to tell. And we are here to read it. Because this isn't just about tremors or gases escaping into the vacuum. This is about something bigger, a chain of events that stretches across billions of years and reaches right into the delicate balance that makes Earth livable. The moon's shifting core isn't just an isolated phenomenon. It's part of a grand, quiet drama playing out above us. A drama that could very well shape the future of our planet in ways we're only beginning to understand. Imagine this. You're standing on the moon's surface. There's no wind, no sound, just the deep silence of a world that hasn't breathed for eons. But under your feet, miles below, something stirs. A long, slow groan as the moon continues to cool, to contract. Its brittle crust creaks under the pressure, forming cracks, ridges, like wrinkles on an aging face. These ridges, called lobat scarps, are young in geological terms, only 200 million years old, a blink of an eye in the moon's life, and they're still forming. Scientists believe the moon is shrinking even now by about 150 feet in diameter every few million years. That doesn't sound like much, until you realize that this contraction puts the already stressed lunar crust under even more tension. The result? Moonquakes, real ones, measurable ones, and perhaps the most chilling of all, deep moonquakes that originate hundreds of kilometers beneath the surface, near the core. Brian Cox's warning starts to make more sense here, because these are not the surface tremors we expected. They're not just the moon shifting in its sleep. They are perhaps the last echoes of internal processes, reaching their quiet conclusion, or the first sign of something we failed to predict entirely. New AI-driven analysis of Apollo-era seismic data has revealed patterns that no one saw before. Signals that were once considered meaningless noise now form a clear rhythm, a cadence beneath the moon's skin. It's like listening to a fading heartbeat, one so faint it takes a machine to even register it. But now that we've heard it, we can't unhear it. And the implications ripple outward. The moon's core, scientists now believe, might not be as quiet as we once thought. Beneath its solid outer layers lies a partially molten outer core, encasing a smaller, dense inner core made mostly of iron, similar to Earth's, but smaller and fading. That molten layer is shrinking, crystallizing slowly. As it does, it subtly changes the balance of mass within the moon, enough, potentially, to affect its orbit over millennia. And what happens if the moon's orbit changes? Even slightly? Earth changes too. Our tides rise and fall with the moon's pull. But its influence doesn't stop at the water's edge. It helps steady our planet's axis. Without the moon, Earth's tilt would wobble unpredictably, throwing our seasons into chaos. Some climate models suggest that, without the moon's stabilizing presence, Earth might swing between extreme tilts, sometimes almost upright, other times nearly horizontal. That means the difference between a livable planet and an unrecognizable one. So when we talk about seismic shifts inside the moon, We're really talking about the clockwork of life itself. The moon is a cosmic gyroscope, delicately tuned over billions of years to keep Earth in balance. A change in its core, even a subtle one, might one day affect the rhythm of our planet's seasons, our climate, even our history. But it's not just the long-term cosmic dance that demands our attention. It's also what lies ahead for us, here and now. As NASA prepares for the Artemis missions, planning to return humans to the moon and eventually build a permanent presence there, understanding the moon's seismic behavior becomes more than academic. It becomes essential. The very places we want to land, near the lunar South Pole, where frozen water may lie hidden in deep craters, could also be zones of tectonic activity. Imagine establishing a base near a fault line without realizing it. On Earth, we've learned that lesson the hard way. On the moon, we won't get a second chance. Brian Cox and others have urged caution, not to stop exploration, but to do it wisely. The moon's surface might seem still, but beneath it lies a fragile network of fractures, stress zones, and possibly active faults. Unlike Earth, the moon doesn't have a system of circulating water to help heal cracks. Once fractured, the crust stays fractured. If we drill without care, we might trigger small collapses. Or worse, awaken deeper stress chains we barely understand. And then, there's the regolith, that soft, dusty blanket that covers the moon's face. It's made of billions of years of micrometeorite impacts, ground into fine powder. But beneath that soft exterior lies a hard, fractured crust. Any mining operation that disturbs it could send vibrations echoing through fault zones. Not in a dramatic Hollywood explosion kind of way, but in slow, creeping shifts. The kind that builds silently, year after year. This is why NASA's upcoming seismic missions are so important. The Far-Side Seismic Suite, or FSS, is headed to the far side of the moon, a place we've never monitored seismically before. That alone is historic. But more than that, the instruments aboard FSS are 30 times more sensitive than anything we've ever placed on the moon. They're designed to hear what we've never heard, to detect the faintest groans of the moon's interior as it adjusts to the end of its geological life. Meanwhile, the Lunar Environment Monitoring Station, or LEMS, will provide long-duration seismic monitoring from the moon's south pole. It won't just operate for a few months like the old Apollo gear. It's built to stay, to listen day after day, year after year. Its mission: to capture the rare, slow quakes that scientists now suspect are reshaping our understanding of lunar geology. These slow slip events are already known on Earth. They don't shake cities or break buildings, but they move continents over time. They shift stress across fault lines, releasing energy not with a bang, but with a whisper. And if they're happening on the moon, they could be the key to understanding its final internal evolution. This is what makes Brian Cox's words so urgent. We're not just spectators to the moon's quiet unraveling. We're participants. And what we do next, how we listen, how we explore, could determine whether we walk blindly into that unknown or finally begin to see the full picture. Because what's happening on the moon isn't just about the moon. It's a mirror. A mirror held up to every rocky planet, every exoplanet we've ever glimpsed through a telescope. Worlds like ours, some larger, some smaller, each with their own stories of cooling, of contraction, of magnetic fields rising and fading. By understanding the moon, we begin to understand all of them. And perhaps, in doing so, we begin to understand ourselves. We are standing at a moment that will never come again. The moon, the silent guardian in our sky, is still alive beneath its surface. Barely. Faint tremors, slow shifts, and subtle pulses from its core tell a story that's nearly over, but not yet. And if we listen closely now, we may learn something that echoes across the universe. Brian Cox's warning isn't about fear, it's about timing. This is our last chance to observe a planetary body in the final stages of geological life. The moon is giving us a rare look into how cores cool, how worlds die, and how even small changes can ripple across billions of years to shape entire planets, ours included. New seismic missions like FSS and LEMS are about more than science. They're about preserving a cosmic moment. These instruments will let us hear the moon's last whispers before silence takes over. And what we learn could reshape how we understand every rocky world we've ever discovered. We thought the moon was dead. It isn't. Not yet. And if we pay attention, if we listen now, with the tools we have and the curiosity we've always carried, we may witness one of the most profound chapters in the story of planets. Before the moon goes quiet forever.